Hey everyone, welcome back to another cybersecurity lab, a walkthrough. In this video, we are diving into an essential topic in enterprise network security, firewall configuration and segmentation. So this lab is where we'll be working on setting up and managing firewalls to control network traffic between different zones, ensuring security and proper access control. In this lab, our main goal is to configure firewall rules that define how different segments of the network communicate. We are dealing with multiple network zones, the WAN, which is our external network, then LAN, which is our internal network, DMZ, which is a demilitarized zones where public-facing services exist, and the management for the management network for administrative access. A properly configured firewall is crucial for protecting the organization's infrastructure. So it helps in preventing unauthorized access, filtering traffic, and ensuring that only the necessary services are reachable from different parts of the network. So what exactly are we trying to achieve in this lab? Let's break it down into few basic objectives of it. First of all, define the firewall zones. We'll be setting up network zones such as WAN, DMZ, LAN, and management, and assign interfaces accordingly. Second thing is we'll be implementing the firewall policies. We'll configure firewall rules that allow or deny traffic between these zones based on the security policies. Then we'll be controlling the traffic between zones, so we'll ensure that traffic flows securely between external, internal, and management networks, only allowing necessary services like HTTP and SSH while blocking the unwanted access. Fourth thing, which is the last thing, is the logging and troubleshooting. So finally, we'll use firewall logging to monitor and debug issues, ensuring our rules work as intended. Now the main question is that why is it important? Well, in real world enterprise network, firewalls act as first line of defense, whether it's protecting sensitive data from external threats or ensuring secure remote access. Properly configured firewall rules is a must for cybersecurity professionals. By the end of the lab, you'll have hands-on experience in managing firewall rules, blocking and allowing traffic segmentation, and analyzing logs for troubleshooting. These skills are fundamental for anyone working in network security, SOC teams, or IT administration. So we'll start it. As you can see that we have our virtual machines which are running over here. I would highly urge you to take a snapshot before you'll start working on it, because there are high chances that some things won't work. So just make sure that you have the proper snapshots before you begin. So let's start with the task number 1 of configuring the firewall rules for Firewall 01. Now we are doing it because we want to control the traffic between different network zones, WAN, DMZ, and WAN. This is an essential part of securing enterprise network and managing the network or the traffic segmentation. As you can see that I'm on my workstation 1, which is over here in my LAN, and we are starting with our firewall zones and linking them to their respective interfaces. So this step is crucial because the segments of the network can ensure that the traffic is controlled between each zone. So in order to automate the process, what I would do is that I'll start my PowerShell over here, and I'll try to connect to my firewall using PowerShell so that we can copy and paste commands easily over here. So as you can see that I'm logged into my firewall, and I'm logged in as a root user over there in a configure mode. Since we don't have any rules in place at the moment, you can see that I can access my Web 01 from my workstation 1. So we started with defining the zone policies. Ethernet 0 is assigned to WAN, Ethernet 1 is assigned to DMZ, and Ethernet 2 is assigned to our LAN. This segmentation is the foundation of our firewall policies. Next, we are setting up default drop rules for traffic moving between WAN and DMZ. By default, all traffic will be denied and the violation would be logged. This would ensure that any unauthorized traffic between these zones is blocked and recorded. So we'll be using the following policies for that. So the policies that I have applied is, first of all, I'm using the WAN to DMZ as drop. And then the second one is DMZ to WAN drop, and then I'm typing WAN to DMZ, which is default logging enabled, and DMZ to WAN as default enabled here as well. So these are the 4 policies. Then you'll just commit and save the changes. Now that we have created the firewall rules, we need to assign them to appropriate zones. So this would ensure that our WAN and DMZ firewalls are applied correctly. Now again here, as you can see, I'm using a zone policy for WAN from DMZ and the policy is that we are setting the zone policy from WAN from DMZ firewall. So these commands would allow the traffic from moving from DMZ to WAN is filtered through the DMZ to WAN firewall, and traffic from WAN to DMZ follows the WAN to DMZ firewall rules. So these are the two policies that I have, as you can see over here at the end of the screen, that the first zone policy is from WAN from DMZ and DMZ to WAN, and the other one is from WAN to DMZ. So now we want to check the policies, the ones that we have applied, and as you can see that we are on our Road Warrior 1, and I would like to ping this web server over here, and let's see if we can reach it or not. As you can see that we cannot reach from Road Warrior 1, which is a remote workstation, to Web01, which is on our DMZ. Since we have a default drop rule in place, this connection should fail, and it is failing. Now if we'll check the logs on our firewall 01, you can see that there is a default drop from DMZ to WAN. Further, it was invoked on Ethernet 1. The source IP is for Road Warrior 1 and the destination IP is for Web01, and it's telling the protocol, which is ICMP. Now currently our firewall blocks all traffic between WAN and DMZ due to default drop rule. Now we'll modify it by explicitly allowing the HTTP traffic, which is port 80 from WAN to DMZ, so that Web01 can serve requests from external users. Now as you can see the rule, this rule tells that our firewall, that any incoming HTTP request from the WAN should be allowed to Web01, which is 172.16.50.3. However, if you want to access the server now, the connection would still fail, because while we have allowed the traffic in, we haven't explicitly allowed the response out yet. As you can see, if I'm trying to access Google from my workstation 01, it does not have access to that anymore. Next is we'll allow establishing HTTP response from DMZ to WAN. So we have the following rules. This rule would ensure that when Web01 respond to requests from WAN, the firewall allows the return traffic back through. This is crucial for web services to function properly. Next is we want to allow DNS traffic from WAN to DMZ. So we need to enable the DNS traffic from the WAN to DMZ. DNS is crucial for resolving the domain names and IP addresses, allowing users to reach the services hosted in DMZ. With this rule, our firewall now permits DNS request, which is port 53 UDP from WAN, to reach our DNS services in DMZ. Without this, domain resolution for public facing services would fail. Now we'll have to configure static route for proper traffic flow. We need to ensure that our firewall knows how to route the traffic correctly between these zones. To do this, we'll configure a static route so that the traffic is destined from our DMZ subnet, which is 172.16.50.0/29, is forwarded properly. With this rule, our firewall has predefined path to send traffic towards the DMZ, ensuring efficient routing and connectivity. As you can see that if I'm trying to access my web server from my Road Warrior, it is accessible through the web, which is HTTP. But if we test the connection from the normal wget command, it would fail, because while we are allowing the HTTP request from WAN, we haven't fully resolved the traffic or the return traffic handling. So we'll have to check on our firewall 01. We are checking the logs, and as you can see, there is a rule triggered for DMZ to WAN with the source IP, destination and source. Now the logs confirm that the request reaches the Web01, but the request is blocked by the firewall on its way out. This is because the DMZ to WAN firewall still enforces a drop rule on outbound connections. Since earlier we applied a DMZ to WAN rule where we allowed established connection back to HTTP, we saw that it was dropping the packets. But now since the rule is in place, and if we try to pass wget again, we can see that before it was a connection timeout, meaning that the response was blocked, but now with the new rule, firewall that we have applied over there, we should see a response where HTTP request is sent and a response is received. Success means that our firewall now successfully allows web traffic both ways, request from WAN and the response from a DMZ. So now we had to create a firewall rule between LAN and DMZ. By default, we want no traffic between LAN and DMZ unless explicitly allowed. So to enforce this, we created a default deny all rules while enabling logging for visibility. Now, as you can see with these rules, with any attempt of communication between LAN and DMZ will be blocked and logged, helping us track potential unauthorized access attempts. Next is we'll be linking the firewall zones and policies. Once we have our firewalls rules in place, we'll need to link them to appropriate network zones. This will ensure the traffic flowing from LAN to DMZ controlled by a LAN to DMZ firewall, and we'll be allowing the traffic to flow from DMZ to LAN to govern the DMZ to LAN firewall. Now with this zone policy, our firewall is actively enforcing restrictions between these two zones. Any unauthorized attempt to access DMZ from LAN and vice versa will be blocked unless and explicitly permitted in later steps. Now let's check if our Wazuh clients in DMZ are attempting to communicate with the Wazuh server but are getting blocked. So to do this, we'll search it on our firewall logs with this command. And as you can see that the traffic from web 01 172.16.50.3 in the DMZ is trying to reach Wazuh, which is 172.16.200.10, but firewall drops the request. Now this confirms that our firewall is blocking the Wazuh client communication. Now we set it up the rules for Wazuh. To allow Wazuh agent in the DMZ to communicate with the Wazuh server, we need to modify the DMZ to LAN firewall rules to allow TCP ports 1514 and 1515. So we had these rules. With these rules in place, the Wazuh agents in the DMZ can now send logs to Wazuh server in the LAN management network. So now we need to fix the issue by allowing the established traffic back. To fix this, we need to modify the LAN to DMZ. So the firewall allows the established connection back to LAN to DMZ. This would ensure that once the connection is initiated, Wazuh can send response without restrictions. So with these rules in place, it would explicitly allow established connections back from LAN to DMZ. So we have our LAN-to-WAN firewall rules. To allow the LAN clients to access the internet, we configured the LAN-to-WAN firewall that would permit the outbound connections while still logging and controlling the traffic. As you can see that the default action is dropped for all traffic by default. Rule is allowing the HTTP port 80 and 443 for the traffic, and the logging is enabled for monitoring purposes. Now with this configuration, users in the LAN can now browse the web, but only over the HTTP and HTTPS. This would ensure that the basic web browsing works while still restricting other outbound traffic. So in some cases, organization may require full outbound access for business operations. This is less restrictive approach, but can necessarily be for the applications like VPNs, etc., remote desktop and cloud-based services. To allow the outbound connections from LAN to WAN, we need to add these rules. With this change, users will now have unrestricted internet access. However, in high security environments, we may want to limit the outbound access to only necessary services such as web browsings, VPN, or email services, etc. So here the logic says that you'll have to link the firewall to the zone policy, but since we have already applied it, and that policy allowed us to have the outbound traffic from LAN to WAN, and now the filtered through the LAN to WAN traffic would be enforcing the rules to be in place. So now we'll try to manage the inbound traffic from WAN to LAN. So with this configuration, any incoming connections from WAN will be blocked by default, while response to legitimate outbound connections initiated from the LAN would be allowed back in. This is essential for services like web browsing, VPN, and secure remote access. Further, if you'll focus that we have applied the zone policy for LAN from WAN, so this policy will also ensure that WAN to LAN traffic is strictly controlled by the firewall, preventing unauthorized access while allowing the valid traffic only. And as you can see on my workstation 1, I have the internet access back before it stopped working when we applied the default drop rule. Now we are restoring LAN to DMZ communication, and we'll be setting up rules for HTTP, SSH, and DNS. So first of all, we configured LAN to DMZ, and we have allowed the traffic for HTTP from LAN to Web01. So likewise, we defined a protocol for port 22 as well, which is our SSH connection from management to DMZ servers. Further, we allowed it for DNS, which is port 23 from LAN to DMZ. So now we are allowing the return traffic from DMZ to LAN, and we have these rules with these settings. Any traffic that is part of the ongoing session initiated from the LAN will now be permitted back from DMZ to LAN. So as you can see, I tried to SSH from my management 1 to my Web01, and it is not letting me in. But you can see that from my management 01, I am able to access my Wazuh server. Now I am trying to configure my firewall management, and as you can see that I'm logged in through SSH to my firewall management. So far we have set up the firewall for WAN, LAN, and DMZ traffic to regulate the communication between network zones. Now we need to ensure a secure access and control over the firewall itself by controlling the firewall management rules. This would allow the administrators to manage the firewall securely while still enforcing the strict access control. To achieve this, we create two network zones on firewall management. One is for LAN and the other one is for management network. So as you can see, I have defined the zone policies over here. With these settings, Ethernet 0 is assigned to LAN zone, while Ethernet 1 is assigned to management zone. This segmentation would ensure that the authorized administrators can access the firewall management services. So now we need to understand the LAN to management traffic requirements. First of all, Wazuh agent communication is through port 1514 and 1515 TCP. So we'll have to allow the Wazuh agent in LAN to send security logs to Wazuh server. Second thing is web access to Wazuh through port 443. We would permit the secure web based management from management 01 to Wazuh. Then we'll enable SSH, which is port 22 on TCP. That would enable the administrators to access the Wazuh securely. And then we'll establish a return traffic to ensure that once the connection is initiated, it returned back traffic is allowed as well. So let's start with configuring the LAN to management traffic first. That would allow the Wazuh agent communication from LAN to Wazuh. So it allowed the TCP traffic on port 1514 and 1515. That's Wazuh agent communication. Then it ensured the security logs from LAN to reach the Wazuh server. Now we'll allow the web interface access to Wazuh through port 443, which is TCP. As you can see, we have allowed HTTPS 443 traffic to access from management 01, secure web-based management, and then it is restricting access to a specific source, for example 172.16.15.10. Now we'll allow SSH access from management 01 to Wazuh, which is on port 22 TCP. And as you can see, we have allowed the SSH port 22 access from management. Remote command line administration would be allowed, and then we are restricting access to management 01, only keeping 172.16.150.10. And now as you can see, I have allowed the established traffic back on my firewall named LAN to management, and it's rule number 100, action accept. It would ensure that the return traffic for active session is allowed, and it would prevent unnecessary connection failures. And as you can see that after the rules, if I'm trying to access my Wazuh server from management 01, it is giving me access through SSH. So now we are configuring management to LAN. So the first thing we'll do is that we'll set the default action to drop and enable logging. As you can see, I have these two rules over there, which would block all unspecified traffic from management and would lock dropped packets for monitoring. Next, we'll allow the management to LAN traffic. So as you can see, we have management to LAN rules. It would allow the management to access the entire LAN, and then it would permit all administrative access to log activities. Now we'll be working on management to DMZ traffic. So this has allowed the management to access DMZ, and it enables the logging back to DMZ. Further, it allows only established connections from DMZ to return. Now we'll allow the established related traffic back to management. So with these rules, it would allow the traffic for established connection to management, and it would enable the related connections for FTP, VPN, and for security, etc. So that's how you can configure firewall management. Now you can dump all the rules from firewall and firewall management so that you can automate the process when required. That's it for today. Thank you very much.